And he is Aditya Gupta.
Yeah.
How many of you uses Android? All right. Oh
Most
my
of
God.
you.
Everyone.
Yeah.
That's good. All right. So,
Okay, so something about ourselves, like we are from a firm called XYSec. It's an information security consultancy company based in India. We do security assessment and web application penetration testing and those kind of stuffs. And we have also find vulnerabilities in companies such as Google, Apple, Microsoft, Mozilla, the ones that have their bug bounties going on mainly.
all right.
And so this is the agenda for today. Just a second. Yeah.
All right. We are
Yeah.
gonna have a quick intro to Android and some Android security architecture. We're gonna discuss about that. We're gonna discuss about Android market and bouncer. Anyone knows about bouncer?
Android
Alright.
bouncer. Okay.
All right. Right.
Right.
Right. Then we're gonna talk about permission model and how we can have a zero permission app. And then we're gonna talk about malwares and botnets. And then in the end, we're gonna talk about a framework called Android Framework for Exploitation. So that's a framework which we made it. So we're gonna show you some demos and stuffs and lots of POCs. And all right.
Yeah.
So
So anyone use Metasploit? Yeah,
of course.
great. So the framework which we have designed allows you to perform similar actions like Metasploit on the Android framework. So you could create like malicious payloads and do application security assessment, find vulnerabilities, leaking content providers, those kind of stuffs. Okay, so the basics about Android. So Android isn't Linux, right? It's based on a Linux kernel which have been modified by Google. Earlier, like devices prior to 4.0, it was kernel 2.6.x, and above that 4.0, it's kernel 3.0, right?
Yeah, right. And it's based on application and software stacks, and a few libraries in C, C++ are there. For example, lib, WebKit and all those. And yeah, right.
Yeah, the applications run inside a virtual environment. Like, suppose you have 3 applications running, so each of them will get separate virtual environment. The first will be running in VM1, the second will be running in VM2, the third will be running in VM3. So the use of running in separate virtual machines is that, like, suppose you have 3 applications running, like Media Player, Facebook, and Twitter. So even if your Twitter application crashes, it won't affect the other 2 VMs, right? So you'll be able to use the other 2 applications in a like perfect manner, right?
All right. And then we have permission models and all right, Android versus iOS, of course. iOS wins. All right. So this is the Android architecture.
Yeah. So like Android architecture is based on levels, right? At the bottom level, we have Linux kernel, which is at the core. So everything that runs on Android is supported by a Linux kernel. And above that, we have some libraries like WebKit and stuff. So anyone have found a bug in WebKit or ever exploited a vulnerability in a WebKit? Okay, so the thing with Android is, like, suppose there is a WebKit vulnerability existing in the PC environment. So if you could just port that vulnerability to ARM environment, you could try that exploiting it in Android, right? The same happened with use after free bug discovered by MJK. So what it did was, it was originally discovered for a PC environment, and he ported it to ARM architecture. So it run perfectly in the Android architecture. And we have the Dalvik virtual machines, that is the virtual environment to run Android applications. And above that, we have application framework and applications. So the thing is, like, suppose you have made a certain application which uses the camera functionality, right?
Mm-hmm.
So it will be in the applications layer, and it will be using the features of the application framework, which in turn will be calling the libraries, and all will be running on top of the Linux kernel, right?
All right. Next comes security architecture.
Yeah.
All right. As Aditya mentioned, all the apps run in a virtual environment, so it's a kind of sandbox, and there is a privilege separation. Then each app has its own UID and GUID, like in Linux, which happens. Then
We have ASLR enforced in most of the places from 4.0. Everyone knows what ASLR is, right?
all right.
Okay. So we have IPC. So suppose each of the apps are running in a separate virtual environment. So in case the one application needs to communicate with the other one, it's need to communicate using IPC, that is inter-process communication. And the Dalvik virtual machine isn't exactly a sandbox. Like any application that jumps out of its Dalvik virtual environment wouldn't could able to touch the kernel, right? So any application could access the kernel and exploit the vulnerabilities. So Dalvik virtual machine isn't exactly a kind of security enforcement.
And then comes, all right.
Yeah.
Then comes security architecture, just like we discussed.
Yeah.
All right.
So the applications in Linux, like the applications in Android, the system applications have either two users, like the root or the system. So the system application could have either root or system, and the applications you install separately and made by developers, not by the system, will have separate user IDs. Like we have here app 78, app 41, app 39, right?
All right. Then
We have a question for you. So which application would you trust? Like suppose you are downloading a game from the Android marketplace. Which of the following application would you trust? Like it is a perfectly safe one. Zero permission? Oh, which one? No one.
what possibly can read logs permission do? Can anyone tell? All right.
Yeah, and more private
Right.
stuffs than just MZ and IMEI.
Yeah, right. So
So we'll show what exactly each of the permissions will do. We have also created a malware with zero permission. The application won't be asking for any of the permission, even the internet permission, and we'll be stealing files from your SD card and uploading it to the internet. So that is quite possible, right?
all right. Before showing you the POC, we'd like to discuss about the permission model over there.
So in case you're an application developer for Android and you like to use certain Android functionality, say you want to use the internet functionality or you want to use the camera functionality, so you have to describe that permission in the Android manifest.xml file. It's a separate XML file in which you have to describe the minimum SDK version, like the minimum version of Android in which you want the application to be able to run, and the permissions you'll be asking, and the display, the layout, all kinds of stuff, right?
So basically, Android manifest.xml contains all the permissions. It lists all the services and all the activities, right? All right. So
how to bypass the permission model? Any ideas?
No ideas. All right. Let's show you.
Okay,
something.
let me ask you. How would you upload the data to a remote server without even asking for internet permission?
Is it possible without asking for internet permission?
Yeah, we say. Just asking, yeah?
Like an IPC to another process?
Yeah, exactly.
Right.
So the basic idea of zero permission application is like any application is able to access your SD card contents without asking for any permissions, right? So you could ask for no permission and you could access all the contents of your SD card. So suppose you take a photo that would be stored in the SD card, you could access it with your application without asking for any permission. So what we are gonna do is we'll take that application or the photo, we'll encode it to base64 and we'll open up a browser with that base64 and it will come to our server logs.
So basically, we made a application like XYZ perm, and you can see over here there is no permission listed over here. It's just the name of the activity.
Okay.
All right. Sorry. Okay.
Just some more.
Okay. All right.
Okay, just mirror displays, yeah.
Huh?
Do mirroring of displays. Yeah.
All right. So now I hope it's clear. All right. So yeah. So you can't see any permission over here, right? You can, and there is just one activity class over here which gets called, and there's no other permissions. So how did we steal the data? All right. So if I can just show you the source. The first thing is any app can read contents from SD card, right? Any app. It doesn't need any permission to read. But to write, you need a permission for external write. But you can just read anything. And what we did is we opened the browser. And any app can open a browser using intent without any permission. So we just opened a browser and we sent the data to some remote location with a GET request with plus RET. So what we did is, if you can just run this app, all right?
Let me see if I have the text.
All right. Uh,
Did you post it to like a web service?
yeah, right.
Yeah, we can do that.
Yeah. So, hold on. Let's show you.
It's kind of scary. It makes me wonder what it's like.
All right.
Golly.
Oh, okay.
Uh,
Okay, log in now.
no.
What's the access code?
Just a second.
All right.
You really want to put that on the screen?
No, this is fine.
You really want to type that on the screen?
Yeah, doesn't matter. Fine, fine. You can access it too. All right. So all the data are saved over here. So right now, all right. Sorry, not this one. All right. Yeah, so all the data which are there is going to get appended to this file, right? So let's go to over here, add AB shell. You just want to connect to devices. All right. The SD card. All right, so we can just cat abc.txt. It says hello. Do you want me to change this or anything? Is it okay? All right. All right. So I'm just gonna run this. All right. So where's the browser gone? All right. So I'm just gonna refresh it. Oh my God, my phone also needs to be connected. Seems so. All right.
Just run it again.
All right. Just gonna run it once again. Should work. All right. And here you go. Appended to the
another
file.
hello. Yeah.
Another hello, right? So it's basically just send the whatever file which is there in this Eclipse, and it sends the data right over here, so we can get the file, right?
The same way is it with like pictures or MP3 or any other stuff?
Okay, so let's go back to the presentation. Before that. All right.
That's there. Okay, so with the internet permission, like suppose you are playing a game like Angry Birds or something, so you guys might think that the internet permission is in order to display the advertisements or something, but with the internet permission, you could have a full-fledged remote shell running from your phone to the server. You could execute all types of command over it, and you could even execute root exploits through it, right?
All right. Okay. Next comes Android applications. Well,
Okay.
everyone knows it. It's in APK format.
Yeah, so Android applications are basically of the format APK, and it's nothing than just an archive file. So you code in Eclipse, you have all the Java activities made up, you have the resource files like the icon and every other stuff, the layout for the application. So what you do when you like finish the application, you export it to .apk format. So it just compiles everything into .apk, which is an archive file. And the thing to note here is like you have all the things made up in Java. So before compiling, it converts everything from Java to DEX format. So DEX is like Dalvik executable, which will be running in the Dalvik virtual machine, like I said earlier. Okay, so if you want to reverse Android applications, like if you're into reversing malwares or any other stuffs, You could use tools such as AndroGuard, APK Tool, Backsmally, or IDA Pro, right?
All right. So basically, this is the difference between a jar file and a text file. How a jar file is processed is kind of the Java code is first converted into Java bytecode through Java compiler, and then you get the jar file, which can be run in Java virtual machine. And in case of
Android
text file-
happens with
Yeah.
Java code. It first compiled into Java bytecode, which is again compiled into Dalvik bytecode. So it will be able to run in the Dalvik virtual machines, right?
All right. Okay. Next comes Android application. It is mainly written in Java,
Java
and a little
plus-
bit of
yeah.
XML. Okay. And nowadays you can write applications Python too. And all right. So it's
Yeah. So it is basically composed of components such as activities, intents, content providers. So what basically an activity does is like whenever you open any application, the first screen which you see, like whichever you interact with, the icons, the buttons, and everything that is inside activity. So and in case of media player application, like suppose you interact with an activity to play a particular song, and even if you like go to another application, this song is still playing in the background. So that is done using services. So services come in use when you have to do some background processing, like uploading some data or downloading some data or playing music or those kind of stuff. Then we have intents. Intents are basically to like use all the components together. Like you could use a particular activity to open another activity, or a particular application to call another application. And then the most interesting is content providers. So like any application stores its data in the Android file system, right? Is it going fine? Yeah.
not
So-
boring, right? All right.
So yeah. So in order to like go to the database and store all the data from the application, you use content providers. So if you are into creating malwares, that will be using. So we'll be like using the content provider to get the contacts. We'll be using content provider to get the call logs and text messages and all the files on the file system. And then we have broadcast receivers. So just like the name, it receives for every broadcast on the Android system. So a broadcast could be like receiving a phone call, getting the boot completed, or receiving an SMS, right?
All right. Then comes Android malwares. These are some of the famous malwares which were present. Right.
So these are some of the famous malwares in the past. The most interesting one was the Janemy, which was a botnet for Android. It was quite widespread, and it caused a lot of financial damage to most of the Android users. So what are the common features in any Android malware?
All right.
So it's able to send SMS to premium rated numbers in order to get money, right? And it then subscribe to premium rated services. Like what happens when you subscribe to premium services is like you have to send a code to that particular service, which will again send back a particular code which you have to confirm. So the malware authors, what they do is like if the victim comes to know that he is receiving or sending any SMS to a premium service, he'll obviously be suspicious that this is a malicious activity running on my Android phone. So what the malware authors did is like if the SMS contain a particular code, it won't show up a notification in the phone. That's what we did in like creating the botnet. Like every SMS the user receives will be displayed as normal, but if the SMS contained a keyword which we have defined to be xysec, it won't show up a notification. Instead, it will execute the command in that SMS. Like we could write xysec shell cat/proc/version. It will send back a SMS with that particular executing command. So the version of that victim's phone will be sent to the attacker.
It's a kind of reverse shell through SMS.
Yeah.
So, anyways, creating a malware.
Okay.
comes.
So just like I said, you could use content providers to steal all the information, and you could write all the information to the database and query the database using cursors. And you have to write long lines of Java codes. And if you hate Java like we do, so you could use our framework.
All right. People should know Java before being into
Yeah.
Android. All right. So if you don't have prior knowledge to like code in Java and do stuffs, you can always use many frameworks which are available free of cost, or you can use Airfree, which does most of the stuffs for you. while it presents you a menu, and you just type in what
Yeah.
thing which you want to cook, and it just happens.
Yeah.
All
I'll
right.
just show you a demo.
Okay. All right. Uh, so should be going to desktop. Sorry. All right, so it's a screen like this with all your options over there. It's like your menu. You can just choose whatever you want to do. So right now I can just see list all the devices, and my emulator is up and running. And for example, if I want to create a malware, and if I don't have a prior knowledge to how to create a malware, or for example, I don't know how to create a malware which can just send an SMS or whatever. So all right, so I can just press 1 for create a malware, and then I can set a reverse IP. The reverse IP should be the IP through which the emulator can communicate with your server. So in this case, I've given my reverse IP, so I'm gonna paste it right over here. All right, then I can change my name of the app, so I'll be giving this name, and then right, so I can then build it. So it's a kind of lunch menu. You just order stuffs, and it's gonna build you the whole package, right? All right, so build it successful. Wait for 6 seconds. All right, no, total time in 6 seconds. Okay, so after that you can just upload it, or there is an APK file which you will find in the output folder, or else you can just upload this malformed APK into the emulator, and what it does is, okay, it starts a Python reverse, server, listening server, which listens to port 8888, and we can go right over here to see this application is automatically launched, and well, I get the contacts come, where name is, write my name, and then the number comes, and then IMEI plus IMSI, and all the details which you want, and everything is all right over here. So you can just go through and write the call logs also comes over here. For example, from this number, the call date in timestamp format, the type, the new, the duration, and everything. So it's a kind of more of like, you don't need to code in Eclipse. You just need to download this framework. So this is just one part of it, right? The other stuffs over here, so you can create a spy bot, you can steal databases and stuffs. Well, before going through all those stuffs, let's talk about a bit of presentation, right?
So instead of setting up the listener, what you could also do is like upload all the information which you have got to the device to a remote server, right?
All right. Okay.
So something about Android framework for exploitation. It is to make your life easier, obviously, and you could find security vulnerabilities in your application as well as your Android device. And all you need to do is to select some menu, and you have to set your local IP and then local port, and you have to build that malware, right? So it will automatically build that particular malware. It will sign it with our certificate. So you could send that APK to any victim, or you could even upload it to the marketplace, right?
All right. I would like to talk about the last point over here. Crypt existing malwares to make them fully undetectable. Does anyone knows how the antivirus checks the applications, whether it's a malicious one or not? So they have a database, all right?
Of
A database,
signatures.
yeah, of signatures of the class names which are there in the applications. So what you can basically do is just create some dummy classes and change the name of the classes which are already there after decompiling that app, and then you can recompile it, so it becomes a FUD. So basically, you can use this framework to do the same stuff. It just automatically decompiles it, changes some class names, adds in some dummy classes, and then recompiles it, and it becomes FUD. All right. So it's all in the negative scenario, right? So it should be something should be there for the positive scenario. So we'll be talking about content providers later on. All right. So this is the process of creating a malware botnet.
Right.
All right.
So next, something about Google Bouncer. So Google Bouncer is a virtual environment set up by Google in order to detect malicious applications. Like what malware authors did is they created a malicious application or created a fake version of any legitimate application, like say Angry Birds or something, and they posted to their Google Marketplace. So a lot of users got infected through it. So what Google came up with is they choose to run every application submitted to the marketplace in a virtual environment, and then look for certain activities and detect whether it is suspicious or not. So what if a malware gets detected within Google Bouncer? So there's always a way. So it has already been bypassed. There was a security researcher named John Overhyde. What he did is what we are doing here is getting a reverse communication from the application. What he did is create a reverse shell whenever the application is launched. So he got a shell from Google Bouncer, and he was able to get all the information from Google Bouncer's device.
So basically, he got a reverse shell from Google server. That's great. Anyways, I think we showed you the
Yeah.
demo for making malwares, right? So we're gonna talk about botnets now.
Yeah.
So
Everyone-
basically, yeah, right.
Everyone must be familiar with botnets in PC scenario, right?
All right.
Okay, so just the same is in Android. We have a master bot and we have certain phone slaves. So whatever the master bot sends to the phone, either through HTTP or either through SMS or through any other communication protocol, so it will basically execute that particular command. So it is harder to detect in mobile phones, and antiviruses generally fail at it in case it's a new malware, right? So with AV, what we did is we took a old malware sample, 6 months old, which was detected by most of the anti-malwares. 30 out of 42 detected it contains a virus. We encrypted it using AFE, and we got a 0 detection. So that's how effective antiviruses are.
All right. What I'm gonna do right now is I'll just show you a demo of the malware. Sorry, the botnet. All right. Yeah, it's open. Okay. So for the botnet, I'll be going over here. All right. So basically, this botnet is a bit of complicated stuff. It just not, I mean, it just doesn't do the what botnets should do. It also gives a reverse shell, so that's better. It's a kind of good botnet. All right. Okay. So now the botnet is installed in this emulator. The best part is you won't see any icons over here. All you can see is it's just installed, and you can just go to settings, and then in the application tab you can see that it's installed, X5 bot, that is. So of course there won't be any notifications too. There's no activities or anything, so it's just a bit of stealth. And all right, just to show you the power of this botnet, what I'm going to do is I'm just going to fire up another emulator. All right. So it's gonna, all right, it's gonna take not much time, I hope. Did it open? All right, it did not open. All right, that's still gone. This should do it.
So what we initially thought while making this botnet is to communicate via HTTP, but while performing tests on a real device, we saw